the MJO is to turn active, and the Jetstream is to consolidate. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 14th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. Just click the Stormsurf icon down there in the lower right-hand corner of your screen. That'll get you signed up so you get the automatic notifications when the videos are posted. And if you'd like to contribute, you may. Just hit the special thanks button down below, the heart with the $sign in it. And with that, I'd like to thank the folks that donated last week. Seasonal Nudge, thank you. Elliot Harris, longtime contributor, thank you, Elliot. Skipper N, thank you so much. Our Predicament, another longtime contributor, thank you so much. And the winner or the big donator for this week is E. Slate, very generous contribution. Thank you so much. And with that, let's get to work. We'll start by looking at significant wave heights for the North Pacific Ocean. We have a developing gale here in the central Gulf of Alaska producing 29-foot seas aimed well at Hawaii. There's also a new gale trying to develop just west of the dateline, only with 18-foot seas right now, but forecast to build rather quickly. So we have a bit of an improving pattern. But before we get into all that, we're going to start by looking at current conditions. We'll start in Northern California, the Point Reyes buoy, 029. We're looking at all the energy that's hitting that buoy from all the way up at 33.3 second period, really long period energy. What do we have, 1/10 of a foot? And you see the same. These measurements are all feet. We see a batch of energy here in about the 14 second period range. Another little batch at 9 seconds, that'd be wind swell. And the graph bottoms out here at 5 seconds. That'd be pretty much pure unrideable wind chop. So we look at these two bumps, we put it all together, we see primary swell 7.2 feet at 13.7 seconds from 292 degrees. That's about 10-foot surf. That might be overstating it a little bit. We also have secondary swell 5.8 feet at 10 seconds from 300 degrees, and that sort of is just bump adding into the mix in the 5 to 6 foot range. We do the same thing down in Southern California, the Point Loma South buoy, number 191. We see that same bump of energy, but it's a little bit higher. It's about a day behind in Southern California what's going on in Northern California. So we see a bump of energy filtered by the Channel Islands in about the 15 to 16 second period range, then some wind swell down below that. Take a look at the analysis here. Primary swell 2.4 feet at 15.7 seconds from 277 degrees. That would be surf in the chest high range, something like that. That might be almost overstating it a little bit as well. Secondary swell 3.2 feet at 6.5 seconds from 276 degrees. Just knee high wind slop, sort of adding some bump on top. And our final stop on the tour, we go to the North Shore of Oahu, Waimea Bay buoy number 106. We see a pretty calm pattern, at least for the moment, with little bumps of energy in about the 11 second period range and the 9 second period range. And look at the analysis here. Primary swell 4 feet at 10 seconds from 114 degrees. Well, that's clearly not right. Making surf in the 4-foot range, and that is about it. So let's go back almost a week. We're going to start on Monday, January 8th. Just see what has happened. This is a significant wave height Hindcast for the North Pacific. We see a local gale on Monday north of Hawaii, but that swell's all but gone. But there was this gale that started developing by the dateline, producing 40-foot seas. Let's see. Right down here, 39.7, that's the highest seas over this entire domain. So we go one more step ahead. This was Tuesday morning, 40-foot seas on the dateline, sort of almost aimed northeast. That system pushed over the dateline, faded, sort of merged with some other energy, created another little batch of fetch and swell or seas in the 24-foot range. That pushed off. Swell, you can see the leading edge of that system. Notice also another gale here developed Friday. So now we're just a couple of days ago producing 32 to 33 foot seas. The leading edge of that first swell, that hit, I think it was actually today, mixed with some other local swell, and that's supposed to continue for a few days. And here we are, current time, actually we can go one more, there we go. Our newly developing gale north of Hawaii and some other energy over here. So let's go look forward. We're going to start with the jet stream, and we're actually, in the teaser, in the intro to the video, we said the jet stream is to consolidate. Well, actually, right now, it doesn't look horribly bad. Winds, so these are jet stream level winds, up about 30,000 feet. We're interested in them because when they help start digging out a trough, a dip in the jet like right there, that creates a counterclockwise flow aloft and down at the ocean's surface. That's the hallmark of low pressure. And if you have low pressure, well, low pressure, if it's strong enough, generates winds. Winds impart energy to the ocean and generate seas. Seas, as they radiate away from the fetch area, eventually get groomed out. The shorter period elements fade, and you get swell. And swell, of course, when it hits your beach, produces surf. All right, so troughs is where it all starts, and it starts at the jet stream level, and it's all about energy in the jet stream. So we see we have up to 180 knot winds pushing from Japan the whole way to a point north of Hawaii, completely consolidated, maybe a little bit of something trying to break out here, but not really, and winds pretty solid, not bad. And we have our trough here. Let's put this into motion. So we get into Monday. Well, there's one trough digging out there. Notice winds build to 190 knots off of Japan. Almost looks like another trough wants to get organized there. But notice there's this big split with the jet pushing way up north and then an inland. That sort of locks down the precip thing for California and the U.S. West Coast. When you have this split jet stream flow, you typically get high pressure in between, and when it's sitting over the Pacific, it tends to be a warmer high pressure. So as we get into Tuesday, a new deeper trough starts building here. This would be north of Hawaii. We'll just put this in motion. It continues into Wednesday and actually digging out more. Notice the split point to the jet, which was north of Hawaii, now moving closer and closer to the U.S. West Coast, with the northern branch sinking further and further south. Two troughs forecast as we get into Thursday with good energy in them. Friday, look at the split point just off the California coast and looking poised to move onshore. Another broad trough developing over the dateline. So we get into Saturday. Here we go. The jet right off the U.S. West Coast, completely consolidated the whole way across the Pacific. This is like kind of a classic El Nino sort of look to it. And then as we get into Sunday, the very tip of the jet just wants to nudge into Central California, probably bringing some weather, and we have anywhere from 150 to 170 knot winds pushing the whole way across the Pacific. Take this right out to the very end. Energy building off the California coast at 180 knots. Certainly looks like an atmospheric river, and look at the tip of that, poised right for Southern California. This is what we've been hoping for a long time. We'll see if it actually happens. Never believe a model out a week, but at least it is teasing us in the best possible way. So next up, we go down, look at surface level pressure and surface level winds. It takes wind blowing on the ocean to impart energy to the ocean to generate seas, which eventually produce swell. So this is, the jet stream is sort of the starting place, the foundation, but this is the actual walls of the building here. And of course, we have a gale, as we saw before, north of Hawaii. Right there's Hawaii with 45 knot winds aimed right at the Hawaiian Islands. A new gale developing here. We put this into motion. So we get into Sunday night. There you go. Good fetch, 45 knot winds aimed right due south of the Hawaiian Islands. New gale starts building on the dateline with winds barely up to 50 knots over a tiny little area. As we get into Monday, as the gale north of Hawaii starts fading out, it almost looks like these two want to start rotating around each other, and they sort of do. You get this sense, though. Look at the fetch pushing right over the Hawaiian Islands as we get into Tuesday night. Probably not a great situation. You got that high pressure from the split jet stream holding off of California. Here comes the next gale, winding up west of the dateline as we get into Wednesday morning with 50 to 55 knot winds to 60 knot winds midday Wednesday, circulating pushing towards the Hawaiian Islands, starting to move towards it as we get into Thursday night. But notice the fetch very far south. In fact, we'll go back and look at this just for a second. I mean, it's a bit north here, but the closer it gets to Hawaii, the further south it gets. I did some of the math earlier this morning on an earlier run of the model. It suggested that actually whatever swell is going to be generated from this could be pretty well shadowed relative to Hawaii by Kauai, but we'll see. The models tend to sort of overhype the stuff, overamp it early on. We'll see if the storm in fact lifts north. Anyway, we get into Saturday, almost a week from now, 35 knot winds north of the Hawaiian Islands. A broad area, just looks like a giant trough of low pressure setting up in the Gulf of Alaska and holding as we get into Sunday and Monday with more low pressure forecast pushing off Japan. Maybe a decent swell producing pattern and a weather pattern for the U.S. West Coast setting up. Let's go look at the effect of those winds on the ocean surface. Right now, 28, almost 29.5 foot seas aimed at the Hawaiian Islands. Put this into motion as we get into Monday. We have 32 foot seas. Yeah, about 32 foot seas peaking out, pushing towards Hawaii on Monday. New gale starts winding up on the date line. Oh, that's a little bit better. What do we get out of that? Maybe 35 foot seas, 37 foot seas. That's actually an improvement from the 12Z run of the model. And that system fades out, sort of coalesces into just this broad area of low pressure and 20-foot plus seas. Just you can see it moving into the Hawaiian Islands as we get into Wednesday. Next gale sets up west of the dateline gale. Actually, it's a storm. We saw the wind speeds over 50 knots is a storm. And here come the seas at 44 feet. Can we get something better? 44 feet over a solid area aimed. Now, this is a little bit further north, so maybe Hawaii, Oahu will be spared. We'll see. Could be a massive west swell or it could be completely shadowed. The system falls south and fades as we get into Friday, the 19th of January, with residual seas pushing to the east north of the Hawaiian Islands in the 23-foot range or so. And then we go a week out. Still a rather disturbed pattern, consistent. This looks good like for just steady 13-second period swell. The question is, what are the winds going to be in Hawaii and how tore up will things get? So here we go. Surface level pressure, surface level winds. Here is Central California, Northern California, Hawaii down here. On Sunday, we have kind of a north-northeast light wind pattern for the Hawaiian Islands. I mean, the surf didn't look horribly bad this morning there. California, northwest winds on Sunday. It was pretty warbled and a mess from a lot of wind. Anyway, we get into Monday. Looks like a better pattern for the U.S. West Coast, at least California, and light offshore flow. Sort of a southwest flow setting up for the Hawaiian Islands. Tuesday, here comes what looks like the beginning of a front. Maybe winds are okay early along the north coast, but then you see south winds start building from about the Golden Gate northward midday Tuesday. Look at this, just southwest to almost west winds, 20 knots for the Hawaiian Islands. As we get into Wednesday, still a light wind regime for California, pretty much an onshore flow for the Hawaiian Islands. Thursday, still winds decent for California. Things may be starting to improve for Hawaii with a lighter flow. Oh, but you still see here comes another low, and here comes this southwest flow again. As you get into Friday, here's the front pushing into California, and kind of a southeast flow, maybe some cleanup for the Hawaiian Islands. By Saturday, first teaser front blows through, but a light onshore flow for California, some sort of a southerly flow for Hawaii. And then we get into Sunday. We're a week out. Here comes the next front pushing into, well, at least we'll say from Santa Cruz northward, and the whole ocean just pushing out of the west, just north of Hawaii. Probably a lot of bump in the water, even if the local winds are okay. Looking at potential for precipitation for California. Here we go. North California here, Central California here, Southern California down here. We are, let's see, that was midday Sunday. Basically everything cleared out. We get into Monday, no rain for California. We get into Tuesday. Tuesday afternoon, there's the Golden Gate, north of the Golden Gate, rain pushing down to Santa Cruz overnight, and maybe just a hint of snow by first light Wednesday for, I'd say, not even Tahoe. This looks like the Yosemite area and maybe the highest elevations around Mount Whitney, something like that. And that clears out through the day Wednesday. Next system, you can see low pressure filling the Gulf here. So we get into where Thursday's clear, Friday, right off the coast, Friday night. First little front trying to push in Friday night into Saturday morning, and making snow only for the highest elevations. Probably just looks like warm temperatures, honestly. And then we get into Sunday. We're almost a week out, much larger area of moisture pushing in. We have one more frame here. You see snow starting to build from, I'll say, Tahoe northward, and then that's the end of the model. Of course, again, a week out, don't believe anything, but at least it's a tease. We look at the snow forecast dashboard for Palisades, Tahoe, formerly Squaw Valley. You can see pretty much nothing until you get to the 20th. Which is Saturday, and then it just sort of starts Saturday, Sunday, Monday, Tuesday, accumulations up into the 52 or 53 inch range. Let's go check some other resorts. Kirkwood, not quite as generous, so about 30, 32 inches. And Mammoth at about 14 or 15 inches. I think the real issue is most of this is moving sort of more north to south, so it gets wrung out at Tahoe, and the further south you go, the less precipitation or moisture there is available to produce snow as you go further south. That said, if the jet stream continues to work its way deep into the coast, then these numbers will likely improve as you get further out. And then back to Palisades, Tahoe. Let's take a look at the freeze level. All right, so this is the base of Palisades, Tahoe at about 6,200 feet. This is the summit up the top of Palisades and Granite Chief at about 9,000 feet. Red, if there was precipitation, red would be liquid precipitation. The gray would be sleet at about 37 degrees. How do we actually mark this? 34.6 degrees. Very conservative here. You could actually get sleet as low as 37 degrees. So the freeze line is right where the white and the gray intersect. So this evening we have the freeze level at just about the top of Palisades, 8,900 feet. You see it going up to about 10,000 feet as we get into Monday. Falling a little bit on Wednesday. There's a little potential. You see the precip potential in here, and, you know, somewhere mid-mountain. And then right after that, another big warm-up with temperatures up to 10,500 feet. Again, the jet and the fronts just starting to tease to pull into the California coast, dragging a bunch of south wind and warm air with it. But then as we get further out here, you see where the precipitation is. You see the freeze level slowly falling down to the base at, let's say 62 or 6,300 feet on the 20th and beyond. Bit of a warm up after that. But there is a sweet spot here if you believe the models. So let's go take a look at wave heights. Forecast wave heights, we're going to do Northern California first, Ocean Beach. As we get into Monday, wave heights in the 6 to 7 foot range, slowly fading down as we get into Tuesday in the 4 foot range, building Wednesday to 5 feet, dropping off again Thursday, and then you see as the fronts approach and the storms approach, surf heights go up into the 11 foot range, 8 foot range, so definitely a building pattern. Also notice the local winds here starting to build from the south at 27 knots on, that would be late Friday, and another big push as we get into Sunday with 30 knot south winds. Swell heights fading from 5.5 feet at 13 seconds, dribbling around down in the wind swell range with periods in the 9, 10, 11 second. Little pulse of swell on Wednesday at 3 to 4 feet at 12, 13 seconds, something like that. And then as we get later towards Saturday, 8.8 feet at 13, 14 seconds. Notice we do not have any big storms near California with sea heights 30 feet or higher. It's mainly all in the 18 to 20 foot sort of range or coming from a long distance, and you get these shorter period waves. That's probably good. It's not death and destruction, it's just playful surf. Moving into San Diego, well, not a whole lot of anything. These little spurts are probably as much wind swell as anything. But then as we get into Thursday and Friday, that would be like the, the 18th and the 19th. Waist-high surf into Saturday, and then Sunday, things building into the head-high plus range. Swell and winds, notice winds very light. Looking at swell sizes, I'm just ignoring, what do we have? 1.5 feet at 13 seconds, something like that. But then finally, as we get into Thursday, 2 feet at 13 seconds, in that sort of range, building to 4 feet at 13 seconds for next weekend. Then the North Shore of Oahu, small surf for now, but as we get into later Monday, Tuesday, 13 foot, down to Wednesday, 10 foot, back to 15 foot on Wednesday, working its way down into Friday, and then for Saturday and Sunday, back up into the 10-foot range. Wind-wise, though, you can look at the arrows. Southwest winds 20 knots here in Tuesday range. They settle down, but still out of the west the entire time Wednesday, Thursday, then back south as we get into Friday at 15-plus knots to southwest at 20 knots a time. So not a particularly good situation swell quality-wise. All right, let's go take a look long-term. What's going on with the MJO, the Madden-Julian Oscillation, and the El Nino Southern Oscillation? These two oscillations are the major influencers of weather and storms and snow in the Pacific Basin. We'll start by looking for signs of the MJO. There's two phases to it, an active phase and an inactive phase. The active phase is like a low-pressure system. The inactive phase like high pressure. The active phase is the good phase, the low-pressure phase. The MJO, the two phases of it rotate east to west around the planet on the equator. Active phase on one side of the planet, inactive phase on the other. It takes about 4 to 6 weeks for either the active or the inactive phase to make its pass over the Pacific. It is the active phase when it moves over the far west part of the Pacific. It does two things. One, because it's a low pressure system, it sucks warm, moist air that's over there on the equator in the West Pacific high up into the atmosphere. That feeds energy to the jet stream. The jet stream then consolidates and builds, and then the more energy in the jet stream, the more energy available to promote storms and therefore surf production and snow and rain production. The inactive phase does the opposite. It's a high pressure system. It cuts off the energy flow to the jet stream. The jet stream gets weak. It splits, sort of like where we've been for the past 2 weeks or so. And then you basically get increased trades. You don't get a whole lot of storm production and not a whole lot of snow. That said, well, we still have a reasonably active pattern in the North Pacific because El Nino is in play. And El Nino is like a long-running active phase of the MJO. All right, so let's take a look and see exactly what's going on. We're going to start by looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. There are wind sensors on those buoys. This is the East Pacific here. This is the West Pacific here. There's the equator. The date line's roughly right there. It's the far West Pacific here. When the active phase moves over here, it one, imparts energy to the jet stream, but also, two, it can reverse trade winds or dampen trade winds. That allows warm water that's normally pulled up here to start sloshing east, not on the ocean surface, but under the equator in what's known as a Kelvin wave, basically a ball of warm water. If the trades reverse, they start blowing from the west or anomalously from the west. That allows sequestered warm water to start pushing east. It takes about 3 months to make the trip from the far West Pacific, eventually impacting the Galapagos Islands and Ecuador, gurgling to the surface, creating a warm pool or slick on the ocean surface. If you have successive active phase of the MJO, just like what we've been having for a year, you get successive Kelvin waves that change the balance of warm water from the West Pacific to the East Pacific, and that's the hallmark of El Nino. We have had 8.5 Kelvin waves traverse the Pacific in the past year, and that's what has given us the El Nino pattern that we have right now. It has taken a year to get El Nino in play. It will not fade in a month or two. It'll take probably a year before that gets all washed out of the atmosphere. I say that because we're right probably at the peak of El Nino, somewhere right around now. But anyway, back to the task at hand. So we're looking at the arrows here. We're looking for signs of the active phase of the MJO. We're looking at the arrow direction just 5 degrees north and south of the equator. The longer the arrows, the stronger the wind. So pretty strong east winds in the East Pacific, pretty strong over the Central Pacific, pretty strong over what we call the Kelvin wave generation area. This area from 170 west, as far west in the Pacific as you can get, 5 degrees north and south of the equator. But it's not the actual wind speeds, it's the anomaly. Difference from normal for this time of year. That's what really makes the difference. And looking over here, well, look at that. One arrow of strong west anomalies, but some other arrows suggesting easterly anomalies. Sort of smells like maybe the inactive phase of the MJO. Certainly here when you get over the date line, east anomalies, and we have no data out here, but in general, looks like the inactive phase of the MJO. Let's go look at the forecast for the next 2 weeks. So here we go. This is the east and west component of the wind. They call it zonal wind anomalies. Is the wind blowing stronger out of the east or stronger out of the west than normal? This is up at the 850 millibar level, up about 4,700 feet, but a pretty good proxy for what's going on at the surface. Now, this is the whole planet. I don't care about the whole planet. Really, all we care about, the most important area is that West Pacific, one for creating Kelvin waves, which at this point really doesn't matter because every Kelvin wave that's going to support El Nino has been created by now, but still active phase also helps move warm, moist air up into the atmosphere, feeding the jet stream. I'm definitely interested in that. All right, so here's the date line right here. Far West Pacific starts about 125 east. So here, now notice this is the past month, and the oranges and yellows westerly anomalies. So this looks like the active phase of the MJO held into about somewhere around January, not even that. You see easterly anomalies started building in the far West Pacific right about the beginning of the new year and have been continuing on through today. Inactive phase of the MJO. The last of the westerly anomalies is going to hold on for maybe another day or two south of California, and then easterly anomalies build over the entirety of the Pacific. Inactive phase of the MJO. Now, though, as we get into the later part of January, notice westerly anomalies forecast to start building. So these are 5-day increments, so only about a week from now. And notice that a week from now, westerly anomalies start building into the Kelvin wave generation area, just as the jet stream is supposed to consolidate, get more energy into it from the previous charts, and the storm track and perhaps precipitation starts building into California. There is a correlation between the two, and it is not just a casual relationship. They are tightly coupled. So let's go look at another mode of the MJO, cloud cover. If the active phase of the MJO is a low-pressure system is typically take warm, moist air, lift it aloft. That warm, moist air condenses as it gets high, forms clouds. So this chart, outgoing long-wave radiation, is just a fancy way of, say, cloud cover. So the oranges and reds here are a lot of sunlight reflecting off the ocean. The only way it can reflect off the ocean is if you have cloud-free skies, high pressure. So this would be the inactive phase of the MJO. And let's get ourselves oriented here. South America, Central America, Hawaii, New Guinea there, EQ, the equator running right there, dateline right there. All important Kelvin wave generation area right over in here. So for today, inactive phase of the MJO in control. 5 days from now, oh, look at that. Active phase of the MJO starting to work its way into the West Pacific. 10 days from now, fully in control of the Kelvin wave generation area. And 2 weeks from now, in control. This per the statistic model. So it looks like the active phase will start in about a week. The dynamic model, well, it's saying pretty much the same thing. We'll look at the two final panels here. Now, this has the active phase moving a little bit slower than the statistic model does. This is the GEFS model. This is the ensemble version of the GFS model that we looked at earlier that was telling us what the Jetstream is going to do. So worst case scenario, that Jetstream model is probably on track, and in a more optimistic world of the statistic models, it might even be a little bit behind the curve. We'll drill down just a little bit here. These are phase diagrams for the same two models, statistic model, dynamic model. How do you read this? Well, the MJO moves west to east around the planet on the equator, from the Indian Ocean to the Maritime Continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. So somewhere getting ready to, in the far East Indian Ocean, getting ready to move over the Maritime Continent. That would be like, maybe the Mentawais or something. The further the dot is from the circle, the stronger it is. So a modest active phase in control. Here, for the statistic model, 3 different paths for the active phase, or forecast tracks for the active phase of the MJO, all putting it in the West Pacific 2 weeks from now. The most optimistic one has a moderate, I'd say, strength active phase, where these other two say pretty weak. We go over here to the dynamic model, the GFS model, and maybe we can slide this over just a little more. There we go. We have a more optimistic pattern with a moderate active phase of the MJO in the West Pacific, or all working its way into the West Pacific 2 weeks from now. So this all looks pretty good, especially starting about 7 to 8 days from now. And then one more flavor of that. This is upper level data. This is a statistic model suggesting areas favorable for precipitation. 5 days a panel, 8 panels goes out 40 days. South America, Central America, New Guinea. 0 is the equator, the date line roughly here. All important Kelvin wave generation area right in here. Now this suggests, but this runs about a week ahead of time, that greens are wet air, so that you could loosely associate that with the active phase, the MJO. Reds, inactive phase. This suggests active phase already starting to build, but because it's in the upper atmosphere, it runs about a week ahead of what happens down at the surface. Either way, active phase out through the end of January, maybe even into the early part of February, and then the inactive phase sets up for most of February, according to this model. All right, so let's go take a look at the CFS model. This is a longer range model. Okay, same thing, east-west component of the wind. The reds are westerly anomalies, the blues easterly anomalies. Now this has the MJO, see right there, black line. The dotted contour, inactive phase of the MJO. Oh, and the date line runs right up the middle. The area we're really interested in is from 125 east, far West Pacific, to about 170 west right here. So we see back late October, inactive phase, early November, strong active phase with westerly anomalies. Late November into early December, inactive phase with easterly anomalies. Massive active phase that basically went the whole month of December with strong westerly anomalies. That's what produced all that giant surf you probably saw on the internet from Mavericks, and then large waves down into all the big wave spots in Southern California. And then here we are now with our inactive phase, easterly anomalies, and not looking particularly good. Week from now, this model suggests some sort of a active phase with pieces of westerly anomalies, but sort of a mixed pattern going the whole way into February. So this is not as strong a single signal as what we've seen in some of the other charts. Let's keep going. Next, we're going to look at outgoing long-wave radiation anomalies, cloud cover, but this is actuals. This is not forecasts. Dateline runs right up the middle. We're going back a year ago, and it's just this area right here on the dateline we're interested. The reds means cloud-free skies. That would be like La Nina, and you can see it here clearly last year in January and February. Dry air over the dateline, probably high pressure. Cloudy skies over the maritime continent. That would be low pressure. This is your classic La Nina setup. Then as we get through the spring and summer, you see the cloudy skies moving from the maritime continent, building over the dateline, solid in November, December into January, while the dry air pattern sets up over the maritime continent. Now notice it is trying to ease into the West Pacific as of now. This is probably setting up the demise of El Nino, at least atmospherically from a producing Kelvin wave and perspective, but probably not having any effect of the storm production machine, at least for the next probably 10 months. All right, now let's go take a look at the forecast. This is outgoing long wave radiation again. Here is the dateline right here. The blue is cloudy skies, and you see this building cloudy sky, low pressure pattern over the dateline to December 29th. Then we took this little hit of drier skies, but then we get from about mid-January on, the model at least teases suggesting a building cloudy pattern, probably low pressure, into at least somewhere in mid-March. Now we switch and we go look at 850 millibar zonal wind anomalies. Again, the east-west component of the wind. Active phase and westerly anomalies, these yellows and oranges all back the earlier part of the year. Here is our current inactive phase with easterly anomalies, but by January 22nd, a week from now, here come westerly anomalies. Forecast building on the dateline region and holding in some fashion the whole way till March. Let's overlay the MJO. Here we go. So here's our current inactive phase. There's your big active phase that happened in December with the westerly anomalies. These are inactive phase. And during a strong El Nino, you really wouldn't expect to see the MJO at all, or if you do, all you should be seeing is westerly anomalies. So this sort of thing here is a bit of a surprise, considering that we're in supposedly a strong El Nino. I don't have an explanation for it. I'm just saying it's there, and it is a little surprising. Anyway, you see again a week from now, here comes the active phase of the MJO. Forecast is set up over the dateline the whole way into the early part of March with westerly anomalies more or less in control. Then here comes inactive phase as we get into early part of March, the whole way through March, and then after that, the pattern pretty much falls apart. Let's overlay the low-pass filter. This is a high-pressure, low-pressure bias. Dotted contour is high pressure. So high. This is over the maritime continent there at 90 east, and that's supposed to hold and then fall apart about a week from now. But the low-pressure bias, well, we are just passing the point now. It's where is this? About 170, 165 west. The peak of our El Nino probably done as about right now. That's with 4 contours of, I'll call it low pressure. That's probably not exactly right, but the general sense is that. The third contour line holds, well, maybe out into the end of February, and it fades. Second contour into April, and then you're into spring and whatever El Nino's kind of, in terms of a El Nino building standpoint, it's over, okay? Whatever momentum El Nino is going to have, it has it now, and now we're going to have to live off that momentum probably for the next year before whatever comes next arrives. All right, so what about the Kelvin wave machine and warm water? I mean, it is warm water that evaporates, that changes the jet stream, that feeds the El Nino pattern. So what's going on down in the ocean? This is the West Pacific here. This is the East Pacific here. This is data, again, from the TAO buoy array. Those series of buoys strung across the equator. I say that they're used for monitoring El Nino, but what they're really doing is they're looking for Kelvin waves traversing the Pacific on the equator. All right? You can literally see the anchor lines on the buoys here, here, here. The X's are the sensors on those buoys. The sensors collect data, use a model to fill in the gaps in between all the buoys, and then you get a profile of what subsurface ocean temperatures look like. We actually have a very good pattern set up here. 30 degrees centigrade anomalies, very warm water. Now it is backtracking because it was as far as, I think 170 or maybe even 168 2 or 3 weeks ago, starting to backtrack. The 29-degree isotherm at 163 west, it was over at 158 about a week or two ago. That said, the 28-degree isotherm, well, it's been locked at about 140, but the past 2 weeks it just developed this finger pushing the whole way to 110 west. So my guess is this is the last push of warm water starting to make itself up to the surface, and it's showing even here. But it is not the actual water temperature. Oh, sorry, the 24-degree isotherm, which is the depth of warm water in the Far East Pacific. Still very solid, deep, and holding. So it's not going anywhere yet. Let's go take a look, though, at the anomalies. That's the mean temperatures. Anomalies, difference from normal for this time of year. You see, just looking here, massive blob of, that's 3, 4, 5 degree centigrade anomalies in the East Pacific. This is the last push. This is Kelvin wave number 8. Kelvin wave number 9 tried to develop out here. You can see 2. There was actually a little lobe of 3-degree anomalies in here maybe earlier today, so that's faded some. But still, this is all warm water pushing off to the east. These 2 degrees, 2.5 degrees here will probably build as they move up. They tend to increase in temperature. So all that says is that there's probably a month and a half, maybe 2 months of warm water out here, still pushing its way up, still feeding El Nino, but after that, we don't think there's anything else coming. Let's keep digging. Here's data from another source, and actually Ben, one of our users here that comments a fair amount and provides some great data, identified that actually this is not purely satellite data. This is a mixture of that prior data, the TAO data, and satellite data combined. So this gives maybe a better view of what's actually going on subsurface. And with that, here you go. Here's your big ball of warm water here off of Ecuador with, what is that? That's probably 5 degree above normal temperatures, and you can see it actually bleeding to the surface in a couple of spots there. But there's also piles of warm water. This is, what is that? 1, 2, 3 shades, 1, 2, 3, 1 degree anomalies or better, all falling south and then going to do that cycle. So there's maybe 2.5 months of warm water here, but the bulk of it is right here bleeding to the surface now. The other point to notice cold water building here. The dividing line about 145 west. It's stable as of right now, but we think as this warm water works its way up to the surface, the cold water is going to come in behind and fill the gap. This is the beginning of the demise of El Nino and maybe the beginnings of another dreaded La Nina pattern. Here's the satellite data used for feeding that previous view. So this is, what is this? This is not temperature. This is the height of the ocean. All right, you have a satellite, rotates polar, here's your planet, polar orbit, just does like this. The Earth spins underneath it. Over a period of about a week, you get a pass over every square inch of the ocean surface. Then you can strip out the wave heights, the wind waves, and the tides, and you determine whether the sphere of the ocean is higher than or lower than normal. Why does that matter? Well, if you have warm water at depth, warm water kind of expands. It will displace the water that's above the ball of warm water. That ball of warm water would be like a Kelvin wave, and so you get a bump on the ocean surface. Cold water likewise contracts. You get a depression on the ocean surface. So there is South America, there's Central America, the equator there, the date line there, New Guinea there. We have 0, +5, +10 centimeter anomalies, and 10, if not 15 centimeter anomalies along the coast of Ecuador. All this suggests warm water. Now, it was out to here, and at one point it was almost out to 170 east, so it is contracting moving to the east as expected. These are Kelvin waves, and warm water from Kelvin waves, they're in motion, they have momentum to them, they are pushing this way, and then they gurgle up to the ocean surface as they impact the Galapagos and the coast here. They have nowhere to go, so they bubble up to the ocean's surface and spew out a fount of warm water on the surface. Now, remember, this is trying to give us a view of what's going on, not at the surface, but down in the ocean, so that we have a view of how many months of warm water do we have. And looking at this, I'd say, we'll say 2 months of warm water before the whole thing collapses. Now let's go take a look at the ocean surface. And you can clearly see, well, let's see here, Chile, Peru, Ecuador, Galapagos Islands, the equator runs right out the middle. There's California and Baja up there and Hawaii over here. Lots of warm water on the equator. The main eruption point right there, you can see it plain as day. These images don't completely overlap, so it looks like there's multiples, but they're not. One eruption point there, but you see this steady there from the Galapagos, warm water. Remember, the trades are blowing from east to west out here, so that warm water getting dragged off this direction off to the dateline. The official El Nino monitoring region, they monitor El Nino and estimate strength of El Nino based on sea surface temperatures from 120 west, that point south of California, out to 170 west, 5 degrees north and south of the equator. So you see, the hottest temperatures are not even in the official El Nino monitoring region, but they are getting caught by trades and dragged off in this direction. So as of right now, as of January 13th, the picture still looks pretty good. And we know from looking at the previous chart, there's still 2 months of warm water subsurface. So again, the fuel for El Nino isn't going anywhere anytime soon. But my guess is we either are or have recently peaked out, and little bit at a time, this is going to slowly start fading in intensity. Sea surface temperature trend for the past 7 days. We'll see a little pocket of cooling right there off Ecuador, but we also see pockets of warming. I mean, this is all pretty much stable. Temperatures have been warm. Yeah, we're getting warm water erupting, but it's not any warmer than what we've had. That doesn't mean that it's not warm here. It's just not getting any hotter, which all in all is a good thing. It means El Nino is still there and still in control. And then here is the backed off view, so you can see the clear El Nino signal, lots of warm water all along the coast of Ecuador up into Central America, out to the dateline, sort of the classic El Nino triangle. We've looked at this from, pretty much every week. I put it in context with previous El Ninos. I'm not going to do it again this week because really nothing's changed. This El Nino can't compete with the 97 El Nino. It can't compete with the 82 El Nino. And one could marginally argue it's sort of like the 2015-2016 one, but I'd say probably not. Still, that said, temperatures are pretty solid. Let's go look at some details on that. These are sea surface temperatures in the Nino 1.2 region, the area right there by Ecuador and the Galapagos Islands. The actual values almost don't matter. Half a degree, 577 thousandths right there. There is neutral there. The point being the trend, we were up at 2 degrees. We were actually higher than that. We were up in the 3 degree range somewhere, I don't know, back in August or something. But steadily cooling. But Nino 1.2 is not the official El Nino monitoring region. The Nino 3.4 region is. Today's value plus 1.396 degrees. Now, this is not the official data. This is data best used to just sort of give you a sense of what's going on. Are we getting warmer, getting cooler? And just to put things in perspective, if temperatures are at zero, actually if they're up to half a degree above zero or half a degree below, that's considered neutral. Half a degree to 1 degree is considered, for 3 consecutive months, is considered weak El Nino. 1 degree to 1.5 degrees is considered moderate El Nino. Now remember, these temperatures are actually 2 to 3/10 of a degree below normal. 1.5 degrees to 2 degrees is considered strong El Nino. Our value today, plus 1.396, really bump that up there to maybe 1.6 or 1.7. But you can see from at least November and probably, or actually from October, temperatures were in the strong El Nino category if you add 0.2 of a degree to any of this. And you can see there was a peak back in November, and here was another peak just recently in December, and now fading a little bit. Here are the official weekly values. This is Nino 1.2, Nino 3, Nino 3, Nino 3.4, Nino 4. This is the one that matters. These are the actual water temperatures. These are the anomalies. This is what matters. The latest value from January 3rd, 1.9 degrees above normal. That would put it strong El Nino, 2 degrees, right kicking on the door of super El Nino, and it was that way for 1, 2, 3 weeks, down to 1.9. Back in the end of November, 2, up to 2.1, and then 1.9. So we are wishing that we would get, you know, like a couple of 2 or 2.1 readings to get us through the month of January, to just maybe say we were at, you know, knocking on the door of super El Nino status. I don't know that we're going to get there, but it's sort of a we'll wait and see thing what happens. I think we're at the peak, so there's another week of data, so that'd be the 10th of January, and then the week that we're in will probably be good too, so that gets to the 17th of January, and maybe, just maybe, we're going to come very, very close to super status, but probably just very strongly, firmly in the strong category. Here's the sea surface temperature anomaly pattern for the past year. You can see the first Kelvin waves is the East Pacific here, West Pacific here. Back a year ago, cold water basically over the entire equatorial Pacific, La Nina. First little Kelvin waves started showing up somewhere here, a little bit of warming in, you can barely read that, March, April, building, and you can see the coverage of the warm temperatures by October, pretty much covering the official El Nino region from 120 to 170, so right in this area here. Solid starting, well, in October, the whole month of November, the whole month of December, and then here we are in January, and you notice the extent, if anything, building more in the eastern Nino 3.4 region, but in the western Nino 3.4 region, that pocket of anomalies there getting thinner, so maybe it's a wash. We'll see. Keep waiting to see those weekly temperature data to see how close we're going to get to the magic 2.0 reading for 3 consecutive months. That's what it takes to reach super status. Let's take a quick look at ocean currents. Here's New Guinea here, the equator right here. The not so good news is you see this easterly current just building and building. A couple of months ago, it was westerly anomalies, or a westerly current almost over the entire equatorial Pacific. This sort of also suggests the demise of El Nino, or at least the foundation. You can see easterly anomalies the whole way across. Let's go look at temperatures. This is the sea surface temperature anomaly. You can see the eruption point right here. I can click these. I don't know that maybe I can do this. Let's even drag this over here. So you can, here is the actual temperature anomalies. These are just little points, 3, 3.6, 2.4, 3.1, but then you get out here and it's 2.6, 2.4, 1.7, 2.0, 2.2, you know, so it's a mix of temperatures, and we'll just go the whole way out here to about the date line, 2.2 degrees. Now here is and actually drag it this way. Here is the sea surface temperature anomaly, actual sea surface temperatures, sorry. You see there is a building broad area of warm water out here, and it tends to move this way during El Nino. During super strong El Ninos, this whole ball of warm water should be over in here somewhere. There's Hawaii, but it's not. It's made it to about this point at 146 west, and that is, let's see, where is that? That's 10 degrees south. It's 5 degrees north and south of the equator that really matters. So, I think what's happening is the easterly current here is taking warm water, pushing it all over here, and we're starting the rebuild process from El Nino, where most of the warm water was over here. Now it's starting to move back this way. Hard to say, but I'd say there's no real obvious sign here that El Nino is going to get any bigger or stronger. I'm not even going to look at the actual Southern Oscillation Index data because we had a discussion about that a couple of weeks ago. And for whatever reason, there's a lot of high pressure in the Southern Pacific Ocean. The SOI is based on readings out of Darwin and Tahiti. Tahiti in the Southern Pacific under high pressure. You see the index here at roughly minus 0.6 or something. This is a 30-day average. It should be down at like minus 20 or 25. And you saw it got in a spike here and a spike there, but it should be steadily reading down there. It's not doing that. We think there is some weather anomalies that are going on that sort of just make the Southern Oscillation Index maybe not a good reading of what's going on in this El Nino, or two, maybe it is a good reading, and that might explain sort of the lack of precip into Southern California and the southern tier states. And yeah, maybe we'll get some of that with the building active phase of the MJO. But if by the end of January we're not in some sort of a pattern, we think that maybe this El Nino from a precip standpoint won't be as good a producer as El Ninos typically are. All right, the sea surface temperature anomaly forecast for the Nino 3.4 region, the official El Nino monitoring region, from the CFS model version 2. All right, so this model last week we looked at, we were just laughing at it because it showed temperatures like plummeting right now. Clearly they're not. They're almost up at their all-time high. So the model readjusted. This is January 15th. It put temperatures at 1.9 because that's what they are. But then it shows them dropping off a cliff. And by, well, let's see, mid-February would be somewhere right around in here. It has temperatures down at almost 2 degrees down to almost 1 degree. I think that is probably a little bit incorrect as well. I would expect temperatures maybe at 1.5 degrees somewhere in mid-February. And I just think the drop-off of this is way overwrought, and it'll at least be milder somewhere out into March and April. After that, it might drop precipitously. But what you can't ignore is the model's trend towards a La Nina as we get into October, with temperatures down at minus 1.65 degrees in October and still dropping. We'll go look at the other version here. The PDF corrected suggests only down to about minus 1.4, but that would be moderate El Nino, and these things tend to run for a year or two. Maybe getting us into strong La Nina territory a year out. Hard to say. I don't put a whole lot of stock in anything this far because we have to get through the spring unpredictability barrier, and come June or so, we'll have a much better handle on where this is all going to go. But for right now, a lot of the models suggesting a developing La Nina pattern long term. The consensus model will be out for next week's viewing, so we'll see what all the other models say and see if they sort of are in agreement with the CFS model. But for right now, the good news is Jetstream looks to be consolidating, roaring, pushing over the date line, and going to build at least for a week. I've gone out and looked at some of the longer range models. 2 weeks out, they say more of the same. Active phase of the MJO coming. Precipitation potential for California and snow. We'll take every drop we can get, fill up the reservoirs and hold on to it tight. It looks like with a building jet stream, then one would assume you have a building storm pattern. Right now, the focus seems to be on Hawaii. Yeah, stormy conditions, but lots of surf. As the active phase moves towards the east, one would assume the center of storm formation would get closer to the California coast, and maybe we'll end up back like where we were in December, where it was a steadily building swell pattern until it kind of went over the top. We think that will probably be where we're going to be come late January, the early part of February, depending on the exact timing of this active phase of the MJO. But it looks like we have another good window for snow and surf coming starting about a week from now. So we're almost there. Hold on and be patient. Our time is coming. Hawaii is going to be up first. We'll use them as the barometer. Beyond that, well, El Nino, will we get to super status? Probably not. We're going to be very close. We'll see. Got another week or two of data to go there to get us till where we know the final outcome. But El Nino is not going to disappear from the atmosphere in a week or two and it's all over. No, it's taken us a year to get to this point. It'll take us a year to undo what we've done. So come December of this year into January, we will still be feeling the effects of this El Nino, even as La Nina potentially builds underneath it. So we still have all summer, and one would expect that the El Nino pattern would help feed the storm track, specifically around the New Zealand area as we get, into the June, well, even May, June timeframe. But that's still, again, too far out. But we'll keep our eyes on that. Other than that, things are doing pretty good. I'd say let's be hopeful and get surf while you can. If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write them up in the comments section. We will reply. And be sure and subscribe. Click the icon down the lower right-hand corner of your screen. And if you'd like to make a small donation, you can hit the special thanks button, the heart with the $sign in it down below. And other than that, go surfing, go skiing, have some fun, be safe, don't get caught in an avalanche. And we'll see you next week. Same time, same channel. Unless maybe I go skiing and then maybe I'll do it a day early or something. We'll play. You'll get the notification if you're signed up and you'll know exactly what's happening. All right, so that's it for this week. See you next week, either Saturday or Sunday. Be safe and take care.